Well, you're ready to take a look at some theory about music and how it relates to the guitar. The first thing we're going to do today is talk about sound. Sound, of course, involves physics and sound waves and all that kind of thing. If you go back to your science lessons, or you're currently studying them now, you know there's a vibration somewhere that travels through air and it hits your eardrum and it vibrates. So if you just go like this on your ears, you can hear your hands touching your head. Don't bam like this, you'll hurt your ears. But if you just touch, you can feel the vibration coming through your skull. If you click your finger over here, there's a vibration being set up that's coming through, and it's making sound waves that are being, the tympanum, which is the drum in your eardrum, is vibrating back and forth, and all those little pieces in there, you got those little tiny pieces in your inner ear, they're going back and forth, and they're translating that into an electrical pulse that goes in your brain. And at this point in your life, you've had a lot of experience of translating those things, those sounds, into things that make sense in your brain. When I speak, you can understand what's going on if I'm speaking clearly, and you understand my language. So I'm sending you sounds that you have come to understand in a way that you can say, oh, I make sense of that sound. There are sounds like that. Whoa, that was a loud sound. There are sounds that are so soft. They are not yet music. So what makes music different, or a subset of sounds? A lot of people talk about this at great length. But the thing that is probably the easiest to understand is tone over time, or a pitch over time. Now, as I'm speaking, my pitch is going up and down. I'm using different ranges of sound, and you could measure these on a scientific measuring device that would keep track of what pitch I'm talking at. When I talk, I'm going up and down, up and down. But when I make music, I'm going to have a particular pitch, and I'm going to, for example, play this low E string, and that pitch vibrates at a certain set of cycles per second. Now here is a pitch. It happens to be the A string on the guitar, and that's something that has been measured in our day and age. It's 440, A440. I'm told it's the dial tone in Austria. It's the pitch that tunes an orchestra. It hasn't always been this pitch for this name. But we're not going to talk about the names yet. Each one of the pitches can be measured. And what actually happens is, if I play this pitch, and I play this pitch, and I play that pitch, they're all related to each other, because this one is 440 cycles per second, that one's twice that, and that one's 3 times the first one. Those particular pitches are called octaves, because you keep doubling how fast everything vibrates, and you get the next octave of that same pitch. So sound that is produced on a tone that lasts through time is the beginning of what we can call music. And an octave is a description of pitches that have a mathematical relationship to each other, that are double each other. I could actually retune my low E string. So now, that's 220, 440, 880, and what's this going to be? When you start getting into all those numbers, I might mess it up. Now we've got 4 different A's. These are called A's right here. All based on their mathematical relationship to each other. Now, people didn't start out saying, let's have a bunch of mathematical relationships to each other. What they did was notice that when they blew a ram's horn, or when they plucked something that was strung and tightened up, that they could get a pitch, and if they did something different, they could get a higher pitch. And they wanted to understand this, and so Pythagoras is one of the people who studied it. He was a Greek guy, and he studied this in Alexandria, Egypt, where they were also studying, and he took a string and stretched it. It was called a monochord, and then he would stop it at different places and measure what was happening and recognize there were some relationships that were repeatable. So in order to understand what he was doing, let's understand string physics for a minute. There are three things about strings which affect what pitch it's going to be. We're basically trying to make a decision in this, is this going to be higher or lower? The first thing we're going to talk about or notice on a guitar, we have 6 different string thicknesses. The low string is an E, while the low string is the thickest, and as you work your way across they get thinner. So that low E string, you see it on the package when you put it on, is the thickest. You work your way across, they get progressively thinner, and the pitch gets progressively higher. This last one is also called an E. So therefore, if a string is thicker, the pitch is going to be lower. If it's thinner, the pitch is going to be higher. The second thing about string physics is if they're loose or tight. Now, if I loosen the string, it gets lower, and it can finally get so low or so loose that it doesn't make a distinguishable pitch at all. So if I tighten that up, as I tighten that string, I'm stretching it. You could do this experiment with a rubber band too. As I go up, as I tighten it, the pitch goes up. So the second principle of string physics is the tighter the string it is, the higher it is. The looser it is, the lower it is. If you can remember with the I, tight, high, and loose, L, low, that might help you. The third thing is the length the string is. Now on a guitar, the string is a fixed length. It starts vibrating at the nut, it stops vibrating at the bridge. And it's not ever going to get any longer. But when we place our fingers down behind the frets, what we're doing is making each string shorter. So when I talked about an octave a few lessons ago, from here to here to here, I've got 3 different pitches that are the same name, and there's the 4th one. I can get that same set of pitches in a different place. If I go up to the 12th fret, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On my guitar, I get that I've just divided the string in half. So now I'm getting, when that pitch rings, it's vibrating twice as fast as that one there. And I can do that with all the different strings. So if a string gets shorter, it gets high, the pitch gets higher. If a string gets longer, the pitch gets lower. So if you combine all these 3 things, when we tune our guitar, we've stretched it as far as it's going to get stretched. So that variable is taken out of the picture. Then we're paying attention to how thick the string is and how thin it is, and how close to the bridge we are and how far away from the bridge we are. Those things are going to determine whether or not we're playing a high or a low note. So I could be playing this note here, which is partway up the neck, but I can play that same note here, which is way up the neck. It looks like I'm playing something a lot higher, but it's actually the same. Or it could be deceptive. I could play this note here, which looks like it's pretty low, and play a higher note here. That makes sense, doesn't it? Because I'm closer. But I could be playing this one here and play this one here, and this is a lower note than that one, even though it's way up here. So we have to reorient our thinking when we're thinking about pitches. If we're very linear in our focus, we're going to say low is here, high is here, or low is here and high is here. But on a guitar, we have that going on, low is here, high is here, but we also have high is here, low is here. So we have 2 different axes that we're working with. And that's one of those things that can trip us up later, but just tuck it away that, okay, when I'm on the lower strings, I've got lower notes to work with. When I'm on the higher strings, I've got higher notes to work with. If I get closer to the bridge, they're higher. If I go lower toward the nut, they're going to get lower.